Hi, I'm Robert Coleman. I'm a Senior Applications Manager at Texas Instruments. Welcome to Power Tips. Welcome to Power Tip 2. In this Power Tip, we'll discuss how you might tame a noisy power supply. If you paid attention to the layout of your power supply, you may not need to pay attention to this particular topic, but many of us kind of overlook traces within the power supply that create problems for us. The low-level control circuits offer ample noise opportunities for us. Here I've shown the low-level circuits in the power supply control and where you might encounter noise kind of problems. For instance, there's an air amplifier in the power supply, and it has relatively high output impedance, and then it has high impedance components around it. So it's very easy to capacitively couple errant signals into, say, the input to the air amplifier, like I'm showing here. You can also inject it on the output, but not as likely. Another place that you can inject noise signals that confuse your power supply is on the reference. I've seen cases where people have capacitively coupled in on the reference and created several hundred millivolts of variation on the reference, which really confuses the power supply. Additionally, we're showing the ramp that is compared to the air amplifier output. This is another possible injection point for noise into the power supply. It's a relatively high impedance circuit, and you can capacitively couple into it quite easily. And then finally, the output of the comparator usually feeds a set of flip-flops, and it's pretty easy to inject confusing signals into this node also. Just for instance, here are two common current mode noise issues. The first one is that in current mode control, the output current may be used as the ramp in the control circuit. And in our case, the blue line represents the air amplifier output, and the purple line represents the ramp, which we're getting from sensing the current in the output inductor. And you can see it at turn on here, this very large leading edge spike. And if the control circuit's fast enough, it might trip on this portion of the current waveform rather than when it was intended to trip over here. And so the way around these kind of problems is to either fix it with a blanking circuit or do additional filtering on the front edge of the ramp. Another thing that's identified in this particular slide is we have cases where the waveform's wide on the current and narrow. This is a subharmonic oscillation that's common to current mode control. And the way that you usually fix that is add some additional ramp into your ramp that you have with the current. Now, how do you tame a noisy power supply? The first thing I usually do with a noisy power supply is I try to verify loop stability. I get a network analyzer and make sure that I have a stable power supply. And then if I feel like the power supply is stable, I try to isolate the problem down to the various components within the power supply. And most likely it's either going to be in the air amplifier, the reference, or in the ramp circuitry. So the first thing I do is I check the linearity of the ramp. That's just as simple as putting a voltage probe on the ramp circuit and make sure that it's monotonic. If it's not, you have some work to do in noise proofing that portion of the circuit. The next thing I do is I override the air amplifier. And many times it's just as simple as taking another power supply, connecting it to the output of the air amplifier, and then varying that power supply output to run over the full duty cycle range. And that's a very simple way to verify that your comparator portion of your circuit's working very well. Then the next thing I do, if I feel like I have a good ramp and comparator, I move on to the air amplifier. And the first thing I do is I get my voltage probe in and look at the nodes, and I'm looking for high frequency signals on the nodes that don't belong there. These would be caused by capacitively coupling into the circuit, or maybe even magnetically field coupling into the circuit. Sometimes I'll find cases where I do have coupling in my circuit board, and many times the best way to isolate that is to take the traces out of the board and air wire on top of the control IC. That is, put the compensation components connected directly to the leads of the air amplifier without any connections into the circuit board. And that's a good way to isolate problems in the air amplifier. And then the last thing I'll check is the reference and make sure it's a nice DC level without high frequency noise on it. Many times the problem in a noisy power supply is the fact that there's improper bypassing on the reference. So thank you for your attention. For more power management design tips, go to Power Management Design Line and search on Power Tips. Or you can click on the link to all articles in the description section of this video. Thanks for your attention.